All right, today we are beginning a new unit. This is Unit 4. We are going to be studying systems of equations. So I think a lot of what you see will be familiar. I think you touched on this a little bit in pre-algebra, but we're just going to do more with graphing equations, solving equations, and kind of putting them together in what's called a system. So if you guys would turn to day one. Day one, we are discussing solving systems of equations by graphing. So step one is to first define what is a system and then what is a solution. So systems, the first vocabulary word here is a system of linear equations. So a system of linear equations is defined as two or more equations with the same variables. Okay, two or more equations. Now we will focus on two in Algebra 1. Two or more equations with the same variables. Two or more equations with the same variables. Our second vocabulary word is what is a solution? So a solution would be any ordered pair that makes all equations true. Now I am going to underline the word ordered pair, the phrase ordered pair. We are going to be writing our answers as ordered pairs because we're going to have two equations within a problem. So that means there is one ordered pair, x comma y, that is going to fit into both equations. Okay, I also want to talk about this graphic right here. So we have solutions to systems can be one solution. Let me kind of highlight here as I talk. We can have one solution to a system of equation. We can have no solutions or infinitely many solutions. So if you remember, we've done equations where we get a no solution or infinitely many. So that will come back here in this section. So if there is one solution, do you see where these graphs intersect? This dot right here I'm drawing. So wherever they intersect means that ordered pair is on both lines. Therefore, that ordered pair is a solution to both equations. So when we draw a graph and we get them to intersect at one point, that is the solution. That's going to be whatever that x comma y is, and that's going to be our answer. What if they don't intersect, like the second one? Well, they're going to be parallel, as it says right here. Therefore, there is no solution. There is no ordered pair that would work in both equations because they never touch. Now, what if you draw, see how this is purple on the screen? If you go to graph a line, and then you go to graph another line right over the top of it, you've drawn two lines, but it no longer looks like two. That means that every single point on the line is a solution. So there's just an infinite number of points on lines. So that's why we have our infinitely, oops, sorry about that. That's why we have our infinitely many solutions as our answer. All right, we will see that a little bit today. Okay, let's add a little bit more in here to help us as we solve a system by, this is called the graphing method. That's what we're going to work on today. So the very first blank, graph both equations. Graph both equations on the same coordinate plane. So I'm going to graph both equations on the same graph. Number two, identify the point. Identify the point where the graphs intersect. Okay, so when I graph them, kind of like in this picture above right here, the first one, where is the point where they cross each other, where they intersect? And then finally, we can check our solution in both equations. Okay, so the important element here is we need to be able to graph a line. So that's what we're going to review this particular section. Okay, notice these first couple examples. The directions say, find the solution to the system by graphing. Write no solution or many solutions where appropriate. So that may or may not be necessary, but we might need to do that. Okay, I'm going to use two different colors here as I graph. So I'm going to do the first one in blue. I might underline in blue. So when I graph this line, I see it is in slope-intercept form. So I can see here that the m is 2 and the b is -2. So when I graph in slope-intercept, I begin with the b. So I am going to graph -2. So the b is the y-intercept. And then my slope is a rise over run. So I'm going to come up here and make it into a fraction, 2 over 1. So I'm going to go up 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Now I'm going to encourage you to keep making dots up and over. And then I like to go back to the y-intercept and go down 2 and the other way. Because I need to have a perfect intersection point. And so unless I have a ruler, I want to make sure I have enough points to make a straight line. So now I'm going to come through here. And even if my line's a little crooked, I still know where my dots are. That's the important thing. Okay, now I'm going to use red. So my new slope here is -1/2. My new y-intercept is a 3. So start with the y-intercept. And then I'm going to go down 1 over 2. Now look at what I did. I just intersected my line. So actually, remember, that's what I want. So do you see on this first picture, I have one solution here. So I probably can stop putting dots there. Now I can go further, but I see my answer. Let's go ahead and finish this out. Okay, so my answer is this ordered pair, but you have to actually write the ordered pair out. So that ordered pair is 2 over 2, and then I went up 2. So that's my answer right there. The answer to the system of equations is the ordered pair of 2, 2. And that's it. So number 1, we have to be able to graph. Number 2, we're looking for that intersection point. And if there's not one, then it's either a no solution or infinitely many. Okay, I would like to do number 2 with you because I want to point out another method of graphing. So let's go ahead. The very first one is slope-intercept form again. So identify the m and the b. So my slope is a 1/2. My y-intercept is a -3. So let's get that on the graph. 1, 2, 3. And then if I go up 1 over 2, up 1 over 2, and like I said, I'm going to do a bunch. So down 1 the other way 2. That's probably good enough. I mean, if you want, you can run off your graph like that. So make your line. Okay, the second one. Now, you can certainly rearrange this in slope-intercept form. Okay, it's obvious, it's currently not in that format. But I'm going to encourage you, this is in standard form. AX plus BY equals C. I'm going to encourage you to do the X and Y intercepts. So remember, the X and Y intercepts are ordered pairs. I'm going to go ahead and open them up here. 2 ordered pairs, where the x-intercept is on the x-axis. So I know it's going to be a number, comma, 0. The y-intercept, if it's on the vertical y-axis, it's going to be 0, comma, a number. So if I go ahead and set up my ordered pairs, now I just need to plug zeros in and do the math. So start with the first ordered pair. Plug a 0 in for y. So that's going to be 3x plus 5 times 0 equals -15. Of course, 5 times 0 is 0, so you can just not write that. And then 3x equals -15, divide both sides by 3, we get a -5. So my x-intercept is -5, 0, so I'm going to graph that. So go left 5, and 0 is right there. Okay, y-intercept. So I need to put the 0 in for x. So 3 times 0 plus 5y is equal to -15. Of course, 3 times 0 is 0. So 5y is equal to -15 divided by 5 on both sides. That's going to be a -3. So your y-intercept is 0, -3. So look what happens when I graph 0, -3. I happen to land on the first line. So go ahead and complete your picture though, and your answer is right here. So the ordered pair for my the solution of my system is the ordered pair of 0, -3. So if you don't actually write the ordered pair down, you haven't found the solution. All you did was graph 2 lines. You haven't actually completed the solution. Okay. Well, I would like you to try 3 and 4. So I'm gonna pause. I would like you to pause the video here and graph both those lines. And then when you come back to the video, I will work through these examples. Okay, this first one is in point slope form. Remember, it's in that y minus y1 equals m times x minus x1. So I actually can use that to graph it. So I can see the m is -2, and then I need a point. And so the point is going to be the x1, y1. So the x1 is 3, and the y1 is 2. So I can plot the point, 3, 2, and then count my rise over run. So it's -2 over 1. So I need to go down 2 over 1, down 2 over 1. Like I said, I like to put quite a few dots. Okay. So there's my first line. And then my second line, let's go ahead and do intercepts again. So let's do a number, comma, 0, 0, comma, a number. So if I plug 0 in for y, I have 2x. Now, when you plug in 0 for y, you can write -3 times 0, or you can just skip that step and go straight to 2x equals 24, divide by 2, and I get 12. Okay. Now, that might be a little tricky to graph, but let's go ahead and leave it for now. Okay, the y-intercept, I'm going to go ahead and not plug in, I'm going to plug the 0 in but not write it. So the 2x is gone. So I am left with -3y equals 24. And then divide by -3, y equals -8. Okay, so if I can't tell the intersection point, I might have to do something else. So here's what I'm going to do. I know it's at -8. But 12 is over here somewhere, but I don't want to risk not drawing a straight line. So here's what I'm going to do. I'm going to rearrange this in slope-intercept form so I can count out my rise over run. So sometimes the intercept method isn't perfect. Sometimes it is pretty beneficial. So let's solve for y. I'm going to rearrange this in slope-intercept form. So take away 2x from both sides. So I've got a -3y equals -2x plus 24, and then divide by a -3. So that's y equals. So -2 divided by -3 is really a +2 over 3. And then here's -8, which is what I got earlier when I did my y-intercept. So I've already got my y-intercept. Let's count rise over run. So up 2 over 3. Up 2 over 3. And do you see how I ran into my line? That's what I want. So let's make our line, but I can clearly see my intersection point. So the answer here is this ordered pair. So that is at 1, 2, 3, 4, 5, 6. And it's -1, 2, 3, 4. So your answer is 6, -4. Okay, last one. Put my blue back here. All right, slope-intercept form. I have my M and my B. So I'm at 2, and then down 1 over 2, down 1 over 2, and then I'll go back, up 1 over 2. Okay. Draw my line. And then I could do intercepts on the second one, or you can rearrange it in slope-intercept form. So if I do a number, comma, 0, 0, comma, a number. So if I plug the 0 in for y, this is going to disappear. So it's going to say 2x equals 8, x equals 4. And then I'm going to do the same thing, plug a 0 in for x, so that term is gone. So I've got 4y equals 8, divide by 4, I get a 2. So graph that, 4, 0, 2, 3, oh look, I landed right there. 0, 2, oh, I'm on there too. So I am drawing another line over the top of the first. So I'm going to go back to the first page. I've really drawn this third picture. So this is our infinitely many solutions. So the answer to this, infinitely many solutions. Okay. All right. We just have one more graph, and then I want to set up a couple word problems with you. Okay, I want you to pause and go ahead and solve this system. All right, I graphed my first one in slope-intercept. My second one, I have to, it's almost in slope-intercept, but it's not quite there. So I'm going to do one more step. I'm going to divide by 5. So I will have y equals, now remember there's an imaginary 1 there. So 1/5 is my slope. 10 divided by 5 is 2. So there's your m and your b. So 2, and then up 1 over 5. I'm going to go down 1 over 5. Do you see how they're parallel? Oops, I don't think I went 5. Down 1, 1, 2, 3, 4, 5. All right, see how they're parallel? And I don't even really need to see that. When I feel like I'm counting the same slope, I have the 1/5 here and 1/5 here. So I have the second box on the first page. I have parallel lines, therefore the answer to this problem is no solution. No solution. Okay. All right, we are going to work on word problems every section, but what we're going to do today is just figure out how to write the word problem. We're not going to solve it. All right. Number 6, at a souvenir store, Sophia bought a total of 11 postcards for $3.45. The small postcards are 20 cents each, and the large postcards are 45 cents each. Let X be the number of small, Y is the number of large, and how many of each did she buy? All right, so I'm going to do some highlighting here on this first one. I have money. All of the postcards added up to $3.45. The small ones were 20 cents, the large ones were 45. Okay? The other thing I have here is that there were 11 altogether. Some were small and some were large. So I'm going to have one equation with money and one equation with the total number. So do you see how the first equation, I am trying to put something times X and something times Y. So if X is the number of small postcards and the small ones are 20 cents each, well, I want to multiply each postcard by 20 cents. So I'm going to situate 20 cents times X, And then the larger ones are 45 cents. And then I spent $3.45 in total. So this first one is all about the money. The second one is, how many of each did you buy? Well, I had some small and some large, but altogether I bought 11. Maybe I bought 10 of one and 1 of the other, or something like that. So this is about, I'm just going to write here, I'm going to write number postcards. Okay? So very often you're going to have a setup where you have money in one, the numbers in the other. So I want you to try that on 7. You're going to have the same setup. You're going to have all the money in one equation. You're going to have all the, in this case, we're talking about types of cones in another. So pause it and give it a shot, and let's see what you can come up with. Okay, $2, $2.50, $565. So 2 times X, because X is the small scoop, 2.5 times Y equals 565. And then some were small, some were double. So X plus Y equals 250 all together. Okay, that's it for our graphing lesson today.